Okay, today we're starting 2.5, which we will do today and tomorrow. We're going to do the first part. We're going to talk about segment and angle proofs. Truthfully, today we're just going over different properties, postulates, theorems, things like that. We'll just like practice some in class on identifying those things, and then tomorrow really we'll go through the actual proofs. Okay, so a proof is a logical argument that uses deductive reasoning to show that a statement is true. A logical argument that uses deductive reasoning. What is deductive? We just took a quiz over this. Based off what?
Not pattern.
Which means it's based off a
Syllabus.
no fact. Deductive reasoning is fact, right? So we're not just looking for a pattern like inductive reasoning. We're using facts to show that a statement is true. Okay? A two-column proof, which again, you guys have seen this because we did two-column proofs on algebra, solving algebraic expressions or equations, is divided into statements and reasons. Okay. All right, last one. A postulate is a rule that is true without needing proof.
What is that word?
Postulate.
No. Postulate?
Yes. Okay, so some of these things we have already talked about. Okay, so you will have seen them before. Some of them I'm just giving you a reminder on what they are. Okay, now the algebraic properties, we spent a whole section talking about these, right? Which you guys used those on our quiz we took yesterday, correct? That very last question that had step-by-step solving the equation, and then you wrote properties, addition, subtraction, multiplication, division, bless you, substitution, distributive property, and then reflexive, symmetric, and transitive properties. We talked about all of those already in this chapter. Agree?
Agree to this.
Okay, so I'm not going to go back over those because you could look back in section 2, maybe section 4. Section 4, right, have a list of all of those properties. Okay? Next to that is segment addition postulate. We have also talked about segment addition postulate because what does that tell you if we do with the two parts? What can we do with the two parts of a segment? Add them, and it's equal to the
Whole thing.
whole line, right? So AB plus BC has to equal the whole line. Everybody remembers talking about that last chapter? Okay. It is important for you to know that that is called segment addition postulate, because when we write our proofs tomorrow and we use something that adds two parts, sets it equal to the total, our reason will be because of segment addition postulate. Okay? No, you won't. All right. Properties of congruence. Reflexive property of congruence just says that if I have segment AB, what is that equal to?
Angle 1.
Nope. Reflexive.
Oh, AB.
Yes. Reflexive is exactly the same on both sides. So AB is just equal to itself. Same thing for angle 1. By reflexive property, angle 1 is also congruent to angle 1. Yes. Callan. Thank you. Okay. Symmetric property is another property that we talked about, right? Was on our quiz also. What does symmetric property say that you can do? Flip it. So if AB is congruent to CD, what else can I say?
CD is congruent to AB.
CD is congruent to AB.
I'll take up this mark.
Okay, which also means if angle 1 is congruent to 2, angle 2 has to be congruent to angle 1. Now, the nice thing for some of us is if we missed this on our quiz yesterday, we're getting kind of a refresher on what these properties are, because again, we will be using them during our proofs tomorrow. Okay? Transitive property says that if AB is equal to CD and CD is equal to EF, then what do I know?
AB is equal to EF.
Yes. Congruent to EF. Right? Same thing on example 2. If 1 is congruent to 2 and 2 is congruent to 3, what else do I know?
That 1 is congruent to 3.
Angle 1 has to be congruent to angle 3. All right, let's go over and look at angle addition postulate. It is basically the same idea as segment addition postulate. It's just talking about angles instead of segments, right? So what this says is that if I take the measure of angle ABC and I add CBD, the one next to it, what's that going to equal?
ABD.
The whole entire thing, right? Which again, we should know 2 angles right next to each other should equal the total thing. Yes?
Yeah.
Okay.
Gracias.
All right. Last 3 we're going to go over are just definitions. Definition of congruent tells you that if 2 things are congruent, what do we know about those 2 things?
They're equal.
They're equal. So if AB is congruent to CD, what do I know?
CD is congruent to AB.
No, I'm not asking you to switch them. It's not symmetric.
Then AB is equal to CD.
Thank you. Then AB is just equal to CD. Anything that is congruent means that it is equal to each other, right? Same example with, we can use segments or angles. What do I know about angle 1 and angle 2?
Angle 1 is equal.
The measure of angle 1 is equal to measure of angle 2. Remember, if we're going to use an equal sign, we have to use measure.
Yes.
Okay? Definition of midpoint. Have we already talked about midpoint this year? What do we know the midpoint does? What does a midpoint do to a segment? Say it again. Okay, it is in the middle, but then what does that tell you about each part? They're equal to each other, right? So, then what do I know? If M is the midpoint of AB, what would we know? Braxton, are you guys talking or listening? It doesn't sound like it. I wouldn't have to ask you that if you were listening. Go ahead. Close.
AM is equal to MB.
Don't use equal. What do we use instead?
Congruent.
Congruent. Segment AM is congruent to MB, right? How would I mark that these 2 are congruent? Yeah, dash through the middle, right? So those 2 segments are congruent to each other. Okay, last thing, again, we have talked about definition of a bisector already. If something bisects, what is it doing?
Intercourse.
It does intersect.
That's what I meant.
Big difference, okay? More specifically, if something bisects, what does it do to the line? Cuts it in half. That's what we're looking for, okay? So if line DC is a bisector of segment AB, what do we know about the 2 segments? They are equal or congruent, right? So AM, segment AM is congruent to segment MB.
Where'd you get the M? Oh, in the middle.
The midpoint here. Same thing for an angle, right? If ray OC bisects that whole angle, what do I know about the 2 angles that are left?
That they're equal.
They are equal or congruent, right? How could I label those 2 are equal or congruent?
With that little line. 0.
What would I call the first angle? There's a better name, an easier one.
Angle O.
Angle 1, right, is congruent to angle 2. Now, it doesn't matter which one you put first. You can say 2 is congruent to 1. But those, anytime they're labeled inside with a number, we can use that. Now, could you call it angle AOC and COB? Yes. Either of those would work. Okay? Do we feel like most of this is stuff that we've seen before and kind of remember? Okay. On page 2, basically your notes today is your homework, okay? I mean, there's not homework because we're going to go over it before you're done, but you guys are going to spend some time looking at the example. It says identify the property definition, theorem, or postulate. So you can obviously refer back to the page we just did, look at your examples, and write in. Is it segment addition postulate? Is it property of congruence, right? What are you seeing happening in each problem? I would definitely write these in pencil so that if we need to correct them at the end, we can. Yes? So I'm going to give you guys, what are we going to today? 20, does that say 26? Let's shoot for like 15 minutes to go through, like you guys to go through this.
Can
And
we
then
just write congruence, equality, or do we have to write the whole entire thing?
you would write property of congruence.
So write the whole thing?
Yes. I mean, you can abbreviate a little bit, but
There's a prop up congruence.
yeah. Okay. Spend some time on that, and then we will go over it before you leave.